Yes, so I'm Ben, this is Clément. We're software developers working at Theodo, which is a startup working with other startups to build products really quickly and for large corporates to work at sort of startup speed. As we're often working quite fast to develop new products, testing is really important to make sure we're not breaking the features we're building and that things work once we leave the project. So we like to think of testing sort of as a pyramid, as lots of people do. So going from the bottom, which is the least complex, more liberally applied stuff like static analysis, up to the top where the more complex end-to-end tests, which take a lot of time to write, but you need on your critical paths. So we start in React, which the talk is about, which I probably should have said. So testing in React. Static analysis, we use Flow and ESLint. Flow for type checking and ESLint for style checking. Then up to UI regression tests, so checking that things don't disappear from the front end, where we use Jest snapshot tests. Up to unit tests, which again we use Jest, which is a test runner, assertion library, and snapshot tool from Facebook to run our unit tests, traditional and ones where we actually mount components and play with the UI. And then for the end-to-end test, we use WDIO, or also Nightwatch, to run a Selenium server and actually simulate actions on a browser for those complex paths that we want to check work. So starting from the bottom up, static analysis. Normally in JavaScript, because it's quite a liberal language, we're used to catching problems in runtime or in code review or on production. But we can fail earlier, fail faster, by using static analysis tools to build upon the type checking in JavaScript and also more enforcement on what syntax is allowed. So a classic example of adding a number to a string, it works in JavaScript, but you shouldn't be able to make 12 from 1 and 2. So when it comes to static analysis, what are your options? You can check style. You can make sure that you're not building very complex code, so you don't have too many variables, don't have too many nested if statements. You can get rid of code duplication by making sure that it's detected and fails your build. And then type checking, which is where we're using Flow, to make sure that you're always making the right operations and you expect the parameters that you get. And finally, there are some security linters, which is static analysis to make sure you're not using anti-patterns on security. There aren't actually any good ones for React yet, but for the back end, OpenStack Bandit is good for Python. And then for the style, complexity and duplication, ESLint is a standard with different plugins and packages. And for types, Flow is a tool we found most useful for React. So ESLint is really easy to install. It's just a yarn dependency. There are two things with ESLint, configs and plugins. So configs say which rules are turned on and which rules are turned off, and plugins define new rules. Airbnb have come out with a really good ESLint config for React projects. So it includes several dependencies, which make sure you've got all the plugins and configurations set for the best practices in React. Some examples from that. So forbids certain prop types. Prop types are where you define what your component expects to get. It prevents duplication of prop types, and it makes you write components as functions when you don't need more complex code. For Flow, where we're applying types to JavaScript, it's a static type checker for JavaScript. You have to run your code through Babel first to make sure that you remove these types before runtime. And then you can just add it with a Flow, add it with a yarn dependency, run Flow, and you can see the code passes. For people familiar with React, you've probably seen we already have prop types in React, so why do we need more type checking? Well, Flow is more powerful because we can do type checking on all of our services and all of the other logic of our code. Also, we can apply types to the state as well as the props, and because we can infer types, it means we get more out of what we specify. A classic example of Flow, not in React, but just in simple JavaScript. If we have the function to square a number, we can see that here we're saying the n is a number, and then we're multiplying it, and if we try and use a string, we'll get an error. The nice thing about Flow, which you don't get with TypeScript, is that it can automatically figure out what your types should be and infer types, so you shouldn't have to specify types for everything. So here we're not specifying the type, but Flow is still going to throw an error because it knows we shouldn't be using a number in multiplication. So in React, if this is a traditional sort of component, so we're using a class, we're extending React components, we're importing prop types from its own library, as that changed in React, and then we're saying the prop types, we've got foo, which is a number that's required, bar, which is a string that's not required, and then we've got a simple render method. If we Flowify this, we can define a type object at the top, with foo being a number, and bar being a string, which isn't required, shown by the question mark. And we can also define types for our states, where we've got count as a number. And then in the angular brackets, just after the class definition, we can specify the types of the props and then the type of the states. And for a functional component, as it's just a normal function, we can say props is of type props, and props is a type we've defined with foo and bar.
Thanks. So now you've seen static analysis. So basically, once you've configured your ESLint, you can use it on every new project. So on all Theodo projects, on all new projects now, we have ESLint configured so that when you start the project, you have your static analysis ready for you. Then you can implement flow as well, but you have to configure it for every file, for every component. Something we like to do as well that is cheap, it's the UI regression test. And for this, we use the snapshots. So this is way cheaper than doing end-to-end tests, and this allows you to prevent any unwanted UI modification. This is what I like to call unit testing your UI. So basically, you have a component, you tell it this is how it should render. So if you've got divs and a span inside, this should render as divs and span inside. So how does it work? We use Jest. So this is a tool provided by Facebook, framework by Facebook. It's really quick to implement. You do yarn add jest and you have it. And to run it, then you use yarn jest and that's it. You can configure it in your package.json to specify the coverage, the threshold, and some other things like which files you want to exclude from your coverage. This is really useful to catch, I'd say, most of your regressions while you are coding, because let's say you touch a button, you add a prop to your button, and you realized while running your test, because your test can run automatically, like you are watching, your test will break automatically telling you that this button was used on another page, so that you don't forget that you should have these props in this new page as well. And it's also useful at code review, because when you create a snapshot, this will create a new file explaining how this component should render, and you commit this file so that then the people who review who will be able to catch if there is any issue. It's also a good practice for you to structure your code, because snapshots can become a real pain if it gets really big, if your components are real big. So it forces you to have really small components. So structuring your code, having really small components. And for instance, if you're familiar with atomic design, it's a really good tool because you structure your components inside different folders. So how does this work? Let's take an example of a footer. So it's really simple. This is a div. It has an ID footer, and I'm using style component to style my div with a color black. How do I snapshot this? Simple. I use renderer create my footer, and then I expect this element to match a snapshot. And automatically, what it will create, what Jest will do when you run yarn jest, is create a snapshot file explaining how this component should render. It will look like this. So it will tell you, for footer renders the component correctly, it will create a class with color black inside and a div with the class name and the ID. And that's it, thanks to two packages, enzyme.json and Jest style components, which allows you to simplify this snapshot, otherwise it's a bit messy. And thanks to this, you can have a trace of how it should look like. When it fails, it will look like this. So yeah, let's say I change the class name because I'm not using style components. I change the class name of the footer to header. Then you will see it directly, and you can assume either I did it intentionally or I need to change it. So these are snapshot tests. Some developers don't think it's a real test because it's really cheap to do, and it actually doesn't allow you to catch any problems. For instance, when you click on a button, if your button doesn't work, the snapshot will not catch this. If all your logic doesn't work, the snapshot will not catch this. But it's so cheap to do, in 2 lines you can have this, that we usually do it on every component. Then you want to test all your logic with unit tests. So how does it work in React? Obviously, you want to test really small things with unit tests. And why do we do this? Because it allows you to understand directly the root of the bugs, whereas if you have an end-to-end test, maybe it breaks when you click on a button, and then you have to investigate why it breaks, what's happening, and it takes you time. And if you have a really good coverage and everything is tested, then you are more confident to code faster. It's really good for us developers to know that if we work on a feature, all the tests will catch what may happen. So that's a big question. Should we aim for 100% or not? I think it really depends on the project, but we can debate about this. I don't know if you're familiar with Redux. In Theodo, we are familiar a lot with it because all our projects use it. And why do we use it? Because basically it's really useful to debug an application. So if you're not familiar with it, quickly, the view represents your components, and the view will be rendered based on the store. So it's like a storage. And the only way you can modify this store is by dispatching an action, up here. And when the store catches the action, it will update. And then the view will say, oh, the store has updated. So if the props I'm using have been updated as well, then I will re-render. So this is the flow that's happening in Redux. I want to focus on this to explain you how we test this. So basically what we want to do, what we want to test is the view is correctly instantiated based on the store. So if you have got a component that is receiving props, you want to be sure it's instantiated correctly. Then when you click on a button, the correct action is triggered to be sure that it will reach the actions. And then you want to test as well that once an action is dispatched, the store updates correctly. Then you've got the whole cycle and you can understand how this works. So how do we do that? We're going to test logic functions, business logic functions, really simple, that can be used everywhere. You're going to test selectors as well. So for instance, your component is using some computed data from the store via a selector. Then you want to test this to ensure this data is in a correct format. You want to test the reducer actions to be sure that the store is updated correctly depending once an action is dispatched. And then the component's behavior, once you click on a button, something happens. So what do we use for this? Jest again, because it's really powerful and easy to use. And Enzyme, a tool created by Airbnb that allows you to, how can I say this, to create a component either by shallowing it, which is really simple. You create a small component and it will render it with props and then you can manipulate it, or by mounting it, where it will trigger the whole Redux flow, which is mounting the element, and then you can fetch element, etc. Let's take a really classic example. I've got a function get highest number, which is a service that takes an array, returns a number. How do we test this? We've got here I got my array. I expect my function to return the correct value. And then I have an edge case. It returns null if I give it an empty array. Obviously, if it passes, then you see it green. And then if it breaks, if someone breaks it, that is not the one who developed it, he will see, oh, I was expected to see null, but I received an empty array. So then you can understand what's happening. Jest is really useful because it gives you a lot of functions like this that you can use on all your cases. For instance, to be null, to be truthy. You can test if your function throws correctly or passes correctly. So that's it. That's the basics of Jest. Then you want to test that your component, if it uses selectors to get data from the store, do it correctly. So you want to test your selectors. For instance, I've got a selector that from the state returns a number, which is in a subreducer. So how do we test this? Well, you mock the state. You create a fake state with a subreducer and your number inside. You test your function and you expect it to return the correct value. And then if it changes, it will break. Then I mentioned it to shallow components. Let's say I've got a component that once you click on it, it should do something. You want to be sure that it does it. So what I will do is shallow my elements. And I will create a function as well. There is a mock function. Thanks to Jest, you can create jest.fn, which is a function you can manipulate afterwards. I will give it to my components, and then I will simulate a click thanks to the wrapper. And I expect the mock to be called at least once. A little higher, if you mount it, then you can test functions like component did mount. So it's something that happens only once the component is mounted. I want to be sure that this function is triggered, so I do the same. But you need to give it a bit more data. You need to give it the store and everything. So that I create again my function here. I create the store with my function inside. And then once I run, just by mounting it, my function should be called. So basically, we tested the whole flow, the Redux flow. What we could do is also test the middlewares. For instance, you could test sagas. It's really straightforward to test because sagas can be declared really easily. So every time you create a generator, you do a next, and you expect the values to be the one you expect. That's it for unit test.
Yes, we've worked our way up to the top of the pyramid. As I mentioned at the start, the ones at the bottom are the easiest to implement and the ones you should have more liberally, and the ones at the top are the ones you should use less, but for the most important parts. And end-to-end testing is the most significant one for this. So it's the things you never want to fail. We use WDIO and Nightwatch for some of our projects. It's not really React-specific. The only React-specific element of it is some components can take a while to mount onto the page, and in those instances, you might need to do some weird timeout stuff. Other than that, it's like testing any other website. So WDIO provides a test runner and also supports multiple test frameworks to run on top of a Selenium server to integrate with your website as a browser. The important thing is do this for your critical paths. So if you're Amazon, you want to make sure someone can put something in a basket and you want to make sure they can buy it. But mainly you want to test the happy cases for that and not every different error message that your application will have. Not only is it expensive to write, but all of these tests will be on your continuous integration. If it takes 30 minutes for every build to pass or even to fail, your developers are going to be slowed down a lot. And these tests can break very easily and sometimes not even because something's broken, just they can fail randomly quite easily. So the testing pyramid we went over from static analysis up to UI regression tests, unit tests and the unit tests that mount and interact with the UI, and then up to the end-to-end tests. The final thing is it's important that these are all in a continuous integration so that on every build into staging or UAT and into production, all these different checks should pass. Your linter should pass on all your files, including your test files, and all the different tests in that pyramid should pass. We use Circle CI, which we've seen to be quite fast, especially since Circle CI 2, but Travis and many other things are quite easy to use. That's everything. If anyone's got any questions, please yell out.